Hello again, everyone. This is our third SPSS lesson, and it is going to cover our same example 1 dataset that was introduced last week, where we looked on, or in the last SPSS video lesson, where we looked at things available under the variable view, such as value labels, variable labels, and the type of scale, width, and number of decimal levels are all things available under variable view. So, as you may remember, example 1, which I'll display now and continue with for the rest of this video, is 35 teacher candidates, some current teachers and some inexperienced non-teachers, and they have been surveyed on their confidence in math, their implicit theory of student ability in math, their procedural knowledge or ability to analyze certain math problems involving ratios, in case you're interested, conceptual skill in problem analysis, and use of math vocabulary. So what we're going to cover is some things beyond just understanding the data, but checking it for data quality. And this is very important because in social science, we very often deal with what is called messy data. And so we need to ensure that our data have the quality that is appropriate for the kinds of analyses that we want to run. So you have kind of two choices with this. You want to start by just looking at descriptions of the data. And there are actually more than two choices. There are many ways to look both graphically and with numerical statistics at characteristics of the data. Most of them can be found under Analyze. If you're looking for graphs, you can find some under Analyze and more under Graphs. We're going to stick with Analyze for the time being. And under Analyze, we're going to look at things that are listed under the descriptives menu. And that would be that where we're going to start is frequencies and descriptives. Because what we're interested in here is not really exploring the data, but just looking whether the data makes sense. Are the data clean? So one of the first things we want to know is to see whether the value labels make sense. So we may have entered value labels, we may have failed to enter value labels, we may have entered value labels that are inappropriate for the data set. So values are applied to nominal or ordinal variables. And so we want to look at output for nominal and ordinal variables on this. And the type of output you look for here is frequencies. You don't look for other descriptive statistics because other descriptive statistics, such as the mean or the standard deviation, are not going to make sense for a nominal variable. If your nominal variable is red versus black, a mean of those two makes no sense. So we're just going to look at frequencies of those types of variables. And we're going to look at the frequency of current teaching, the frequency of their highest degree using not that string variable that we looked at last time and didn't like, their frequency of sex, race, and that's all. You will notice that, first of all, these little dots mean they're nominal variables. This means that it's an ordinal scale. To get them into the list of variables. This presented the list of all variables that were available for this kind of analysis. This is the list of variables that we actually have an interest in, and we just click on one, click the arrow to move it into the other menu. To get frequency tables, the nice thing about the frequencies drop-down, which again is under Analyze, under Descriptives, is that frequencies is the default. Display frequencies is always checked. Now that sometimes you don't actually want the frequencies and you forget that this is checked and you go ahead and get the frequencies and they're not particularly desirable. But in this case, we want the frequencies. So I'm going to make sure that you can see the output, which I don't think you can. And here you can now see our output. So first of all, you see that there were no missing values on any of the cases, which means that a missing value would be that one of the participants had omitted to answer the question. And so there'd be a blank spot instead of a value for that question. So that's nice. We have a complete data set. Everybody in the data set has answered all these questions. Current teaching, you'll notice that because we put in value labels, we have a no or a yes for current teaching for all participants. Otherwise, we would just have a 0 and a 1, and we'd have to realize what that meant. This is your frequency column, as we covered in class, your total, which should be the n, your relative frequency, or frequency percent, your sum of your relative frequencies, which should always be 100, your valid percent, which is adjusted for if they're missing data. So your percent will have a divisor of 35, whereas your valid percent will omit in the, denominator, a denominator of 35, your whole sample, where a valid percent will take that 23 out of how many people actually answered the question, not the whole sample. And your cumulative percent is the sum of your percents. So we have that. Knowing Hunter College, it makes sense that most people are not current teachers. They are seeking to be teachers. Most of them have acquired a BA, which means that they're probably in a master's program, and very few of them already have a master's. 8.6 or 7%, or I'm sorry, about 9% have already acquired a master's, so they're probably working on a master's plus 30. But we don't know that, but none of them have, as a matter of fact, master's plus 30 was a choice on the survey. So they're working on just their certification. The majority, 89% approximately, are female. Again, not untypical, particularly these are all childhood education teachers. I hate to generalize, but it's true. And race, the proportion of the what do you call it? Spacing, the word when you don't have a single majority, but you have a group that has more than any other group, is white at 37%. And so that's what you see. What we want to see is there are no missing data. There are no cases that had numbers. For instance, nobody had a number in the original data set that doesn't have a value label. So nobody in the original data set, go back to sharing that with you. If we look at data view for gender, for instance, if there were a 3 in there, then 3 must have been an allowable category, or it wouldn't have made it into the data set unless it was a mistake. And I just kind of happened to know, but it doesn't matter. somehow it made it into the data, and you would see it in the output. 3 would occur. Let's just actually make it up. Let's see if you see this live. Oh, I have to check and see whether, yeah, I think you saw that live. And so I added in a 3 for gender. Okay, so if I go up to analyze again, descriptive statistics again, frequencies again, and to get rid of these, by the way, you can just click them away. I could have asked for the whole thing at once, but I don't want to. And if we run this again, then what you're going to see on the output is that all of a sudden there's one person who has a 3. They have no value label. I don't know what they are. And that is likely a mistake. If that's not a value that I considered eligible, that's probably a mistake. And now you need to go back to those data, the raw data. You need to figure out how a 3 got in there. Sometimes, very often, this would mean going back to the physical surveys and finding that case number. So that is case number, my mouse is stuck. Great. Hopefully, there it is. And and this is case number 45724. So you'd have to look at the responses for 45724. Oh, I'm sorry, 45715, and figure out how that 3 got in there. If you cannot, if there is no valid value for 3, then you have to decide, are you going to treat the whole case that has the 3 as an invalid case? Or are you going to mark gender for that person as missing? If you want, this is a little more complicated than I intended to go, but if you want to mark gender as missing, there's actually a way to do that under variable view. And what you do with your, I guess you can, yeah, you can see variable view. What you do with your variable view is under gender, where there's missing, you choose that you want to say that a value of 3 will be treated as missing. And what that means is that you have told SPSS that if they see a 3, they should treat it as a blank. And that is because you went back to the data, there was this 3 sitting in the data for gender. 3 doesn't mean anything. So you're trying to figure out what the 3 means and what to do with it. You go back to the data. You can find no earthly reason why there should be a 3 in there. The person didn't write down 3. What may have happened, maybe they didn't write down anything. For some reason, which you explore, this is a detective job, you still can't find out. All you can find out is that that's wrong. So you tell SPSS, all I know about this is that it's wrong, so I want you to treat it as if it doesn't exist at all. Often you can actually find out what happened with something, and we'll see some examples where you would be able to find out. But I'm going to go back, and now I'm going to analyze this one more time. Descriptive statistics, frequencies, gender. And we will get a different output because I've changed something. So I'm going to say, okay, then go to, excuse me. So you see the output. And now you only have 34 cases. You have the same number of males, 4, the same number of females, 30, But instead of this 3, what is that one person? You have a 3 that is treated as missing. And now, an interesting thing is that your percent and your valid percent will change. So your percent is 4 over 35. The total number of cases in the data set are the percent of cases in the data set that are male, the percent of cases in the data set that are female, and 2.9 is the percent of cases in the data set that are missing on that item. 11.8 and 88.2 represent the percent out of 34. In other words, of those people for whom you know gender, 11.8% were male. So it's out of the total of 34, rather the total of valid values. That's why it's called a valid percent, valid values rather than out of the total possible values. So that's how you deal with the missing data point. When you code it as missing, the world of what to do with missing values that you don't want to consider missing, you want to somehow or other get a value for them, and you can't find them in your data files, is more complicated. And mostly we'll not get into that in this class. Okay, so back to exploring the quality of the data. We now have all these continuous variables. And we have two choices for looking at the continuous variables that we're going to use in the first part of this course. They're both under descriptives, and they are the frequencies menu and the descriptives menu. Let's look at the options for each of them in turn. I wonder how I make sure that you're seeing. I can't make sure that you're seeing that. Okay, so I'm hoping that you can see this. I'm pulling down the Analyze menu, going over to the Descriptives tab, and I get Frequencies and Descriptives under there. And I'm going to choose Frequencies first. You're not seeing this, and I wonder if you've ever seen them. All right, going back to that. Analyze menu, Descriptive Statistics menu, we're going to look at frequencies. So in this case, we don't want gender as sex, we want continuous variables. So for instance, math competence. And statistics is an option. So we're going to look at what's available under statistics. You can get to quartiles, which will be covered in an upcoming class, percentiles, mean, median, mode, so a lot of different central tendency, skewness and kurtosis, which have to do with the shapes of the distributions, and measures of dispersion, standard deviation, variance, range, minimum and maximum, and the standard error of the mean. There's quite a number of choices. And then we're not going to go beyond that, except to note that if you are looking for a scale variable or an interval or continuous variable with the frequencies command, you always want to uncheck display frequency tables, or you'll get a lot of garbage that you don't want. I'll probably show that in a minute. But first, I just want to see, alternatively, what's your choice if you choose descriptives? If you choose descriptives, for again, competence, your options are actually fewer. By default, that means it's already checked. You get the mean, the median, not the median, the standard deviation. You can get the variance, you can get the range, the standard error of the mean, the minimum, the maximum. You can get skewness and kurtosis. I don't really recommend skinous and kurtosis as statistics, but you can get them. There are a number of things you can't get. There is one, including the median, there is one thing that you can get, which is save standardized values as variables, which will give you z-scores, which we will cover in another class. Because I can get the median, I usually prefer frequencies for getting descriptive statistics. There are a lot of ways to get them. And sometimes if you want things that aren't available under one menu, you're going to have to use multiple menus. So we're going to reset this completely and go in and put in our scale variables. Notice I can hold down with the Shift key and choose a bunch of these. I can also, if I hit the Control key, I can choose multiples that aren't in order. So I'm going to ask for the statistics. I'm going to ask for the mean, the median, the standard deviation, the minimum, and the maximum. Hit continue. Uncheck this. If I checked it, every single increment of a response on the mean. So one person got a 4.2, one person got a 4.21, kind of like that string variable. Not going to be useful. So I'm going to hit OK. I'm going to go through the output. So first of all, what do we see? Oh, shoot. I didn't uncheck this. So you see my point. Every single unique value has a frequency of like 1 or 2. I've got to go and see. I talked about unchecking it and didn't. Okay, so now I don't get all that not very useful output, and instead, the first thing I see is that none of the participants are missing on any of those variables. The second thing I see is that the mean for math confidence is 3.7 with a median of 4, standard deviation 0.8, minimum, maximum 2, etc. 2 and 5. And you see procedural knowledge, all of that for procedural knowledge, and so on. And you see theory of ability, and it has a mean of 17. Standard deviation is outrageously huge, and the maximum score is outrageously huge. Well, I'm immediately thinking, what? And I happen to know about that theory of ability scale that the number of total points available for that is not more than 7. Again, honestly, remember whether it's 6 or 7, but it's not more than 7. So these values that there should be a maximum of 523 make no sense at all. So what am I going to do? I'm going to go back to my raw data. I'm going to go into variable view. This way you can see everything I'm doing. You haven't seen some of the things that I'm doing. And there are a lot of ways to find out where the case with 523 lies. It just happens to be popping up right here. One of the easy ways to make it pop up is if it's outside the range, you can go to data and sort your cases just like you might do in Excel. And so I could sort them by theory of ability. And then my theory of ability is going to pop up on my data file at the with that outrageous value of 523 at the bottom. And you'll see otherwise scores don't go anywhere between 1 something and 4.75. So this is a crazy value. Sorting, there are more sophisticated ways to identify a case with a specific value, but not necessary for this course. So 523, what do you do with it? You go back to the original data. And whenever you have strange values, you don't just delete them. You don't necessarily even code them as missing. What you do is you go back to the original data. And let's say I run back to the original data and I look and I see that the person who took my surveys and then transcribed them into SPSS or an Excel spreadsheet, took a 5.23 and didn't put in the decimal place. And that changed into 523. In this case, I could feel confident changing it. Otherwise, I have to decide, am I going to delete the whole case or am I going to mark that value as missing? Your decision. So that's the researcher's decision, and it has to be made carefully and it has to be documented. Let's see. Generally speaking, there are a number of cases that you can run into when you are cleaning data. We've already looked at what to do with string values. I didn't really show you how to recode them. I just showed you try to avoid them. Some of the things about missing values. We didn't look at multiple responses. You would usually see that if you had a paper and pencil survey where someone checked or circled 2 choices. So they were saying how much they agree or disagree with some attitude, and they checked both 3 and 4. You have to come up as the researcher, you have to come up with a decision rule for that. If you're a research assistant, you have to know what the decision rule is by going into your code book, or sometimes you have to create the code book. Identify, create your decision rule in conjunction with the researcher, and apply it. So what I do, my most common decision rule when people circle multiple responses on a scale, say if it goes 1 through 6, is if they're adjacent responses, say 3 and 4, I take the average. If they're non-adjacent responses, I treat them as missing data. But all those things have to be decided. Implausible responses, as I said, go back to the data. Missing values, go back to the data before you do anything. And with implausible and missing responses, you have to look at the level to which the case is corrupted. If it's maybe just one variable, maybe you don't have to worry about it, just mark it as missing and then ignore that data point. If the case has a lot of missing values, so these have 35 cases, if you count the people who had the theory of ability value that was weird and the people who were missing, the person who was missing on gender. But originally this data set had like 80 people in it, and it was an online survey and a lot of people didn't complete it, and we dumped a lot of data. Okay, so that's the end of this. Hopefully I don't need to redo it. That's private between me and you. And I'm now just going to show you how to save these data. You go down onto Save As on the File menu, and if it's the first time, then you save it as a new name, or if you want to rename it because you've made some adjustments but you want to freeze the original, then you would give it a new name. So let's say that I want to name this example 1B. It's not a very explanatory name. I like explanatory names, but in this case, I'm just demonstrating a save as. Otherwise, it's just command as. Without doing that, actually, what I want you to notice is if up in this corner, there's a little star next to the document name, it means it hasn't been saved. Any changes that you've made to it haven't been saved. And that's something to watch out for, because if you make big changes to something and you made them by mistake, then it can sometimes happen that if you didn't save your own version, you can't undo. So I'm just going to save this with its original title, and then I am going to head out. See, how do I get to this screen? So Until next time, bye.